Hello, today we are going to discuss um, a method known as cylindrical shell method for calculating the volume of solid of revolution. Yesterday or the day before we discussed disk method, and we discussed washer method. But today we are going to discuss another method known as cylindrical shell method. Um, we're going to use shell method to find volume of a solid of revolution formed by revolving around y-axis. We will use shell method to find the volume of a solid formed by revolving about the x-axis. So cylindrical shell looks like this. So if I revolve a region around y-axis, I'm going to find a volume of revolution. To find the volume of the revolution, we are going to use a method known as cylindrical shell. So first we partition this region into thin shell and find the individual volume of the shell and sum them up to find the volume of the to find the volume of the revolution. Sewer line and water pipes are example of cylindrical shell. In case you don't know what cylindrical shell looks like. Okay, so to find the volume of a solid revolving about the y-axis, first, if I revolve this region about the y-axis, I'm going to obtain this volume of this solid of revolution. To find the volume of that solid, we divide this solid up into thin shell and sum up the individual volume of the shell to approximate the volume of the solid of revolution. So first of all, the region is bounded between A and B. We partition the region into subinterval x of 0, x of 1, x of 1, x of 2, and then let's assume that we have in the middle a subinterval x of I minus 1 and then x of I, and then at the end we have the subinterval x of n minus 1 x of n. So we would say delta x is going to be equals to b minus a over n. Here let's say I is equal to 1, 2 up to n, and then we know that x of 0 is equals to a, and then x of n is equals to b, and let's assume that use of I, which is, let's assume that this is a midpoint here at this subinterval, is going to be equals to x of I minus 1 x of I divided by 2. And so to find the volume, V sub I is going to be equals to 2 pi times U sub I, basically the circumference, right? The average circumference times f of U sub I. So that's the height times delta x. Okay, this gives you the volume of this cylindrical shell, But to find the overall volume of all the shells, so let's make this V here, it's going to be approximately equals to summation of all volume of cylindrical shells is 2 pi u sub I times f of u sub I delta x. So, and then in order to find the exact volume, we're going to take the limit. So we're going to say the volume exactly. It's going to be limit as n goes to infinity. Okay. Summation from I equals to 1 up to n of 2 pi u sub I. That's the circumference times f of u sub I. That gives you the height and delta x. So when we take the limit, what we basically do is that we partition the region that we are rotating about y-axis into infinite number of subinterval, and then when we rotate this subinterval, we actually create an infinite number of cylindrical shell or thin cylindrical shell. So we find the individual volume of this thin cylindrical shell, and that gives you an approximate or the exact volume of the solid of revolution. So when we take the limit of Riemann sum, we get integral. So here you realize one thing, that when we rotate a volume around y-axis, we find the volume in terms of x. Okay, the function of the volume is in terms of x. This is unlike the disk method and the washer method. To find the volume of a solid revolving about the x-axis, we do a similar derivation. So here we say, let's have y, so y of 0, y of 1, and then y of 1, y of 2, and then in the middle we're going to have y of I minus 1, y of I, and at the end we're going to have y of n minus 1, y of n. So what did I partition? I partitioned this interval into n subinterval. And then we say delta y is equals to d minus c over n. So here I have I is equal to 1, 2, all the way to n. So we're going to find, so first let's say v sub I. V sub I here is the midpoint here. V sub I is going to be equals to y I minus 1 plus y sub I divided by 2. So V is going to be equals to 2 pi V sub I times G sub V sub I times delta Y. And then when we to find the volume, the overall volume, the approximately equals to summation psi goes to 1 all the way to n. of 2 pi v sub I times g sub v sub I delta y. When we take the limit, we get this integral. So the limit should give you the exact volume.